Okay, so after computing the sum of square between and within, getting the degree of freedom of between, which is 5 minus 1, you get 4, and within groups you get 15, total is 19. You can get the mean square by dividing the sum of square over degree of freedom. So 1478.8 divided by 4, you get 369.7, and if you divide 305.01 by 15, you get 20.334. These two values are used to find the F calculated or test statistic. So the calculated value of F is 369.7, which was MS between, divided by 20.334, which was MS within. So you get 18.18. This is calculated value. What we know in hypothesis testing, we have to compare the calculated value with the table value. So how we get the table value? Table value, we get it using the F distribution table. This is F distribution table at alpha 5%. We look at the degree of freedom of numerator. Numerator means the degree of freedom of between, which was 4, because we have 5 systems, so 5 minus 1 is 4. And then degree of freedom of denominator. Denominator degree of freedom, it means we are talking about within degree of freedom. So that was equal to 15. So cross these two, you will get the value as 3.06. That is F from the table. Now comparing the value of calculated value and the table value, we can see that the calculated value was 18.18 and the table value was 3.06. So this one is greater than this. It means we reject H0. What was our H0? In H0 we said that all means are equal. So we are rejecting that. It means at least one has different mean. It means we are accepting the alternative hypothesis. So in general, what we are doing in Anova, what we did in hypothesis testing, we state the null and alternative hypothesis. We select the alpha. Most of the study, they use 5%. We use F distribution to compare the mean between more than 2 groups. Then we compute the summary statistic, the sample mean, the sample variance. Then we compute the sum of square between and sum of square within. We fill the Anova table. From the Anova table, we can see the F value, the F calculated, and we compare it with the F table. Then we make the decision whether we reject the null hypothesis or we accept the null hypothesis. That's all for one-way Anova. Next video, I'll talk to you about two-way Anova. Now, one thing I forgot to mention, that we can perform Anova in one click in Excel. There is a tool pack in Excel called data analysis. You can perform this using the data analysis, okay? So I will show you that. So this is the tab which we have to use, data, and you will find here data analysis. If you don't have these tools, how to get these tools? You go to File, Option, Add-ins, and then Analysis Tool Pack. Press go, and then if you tick on this and then press OK, you get this data analysis tool available in Excel. So how we can perform ANOVA using Excel? Directly we get the ANOVA table. This is one way ANOVA. We have only one factor, which is system. We have classified our observation by system. So that is only one factor. We go to data analysis, and then we click on ANOVA single factor, because it's only one factor. Then we select where is our data. So we will select only this data. Without selecting the system, we have to select only this range. Group by. Your systems are written in groups of rows. So group by rows, because they are written in rows. And label in face column you don't need, because we have only selected the numbers. Alpha is 5%, so 0.05. You press. So these are the value you get it. Okay. Now, if you see here, you can see that this is sum of square between, and this is within. This is the degree of freedom, MS between and within. This is the F calculated value, and this is the F table value. You don't need to use P value, okay? And else you can see that you can get also the sample mean for each group, and sample variance of each group, and the sample size. So that's all for Excel.